Good night to Sir Eliando and everyone. I'm Angel Christopher. And since I missed out on site main exam, I'm going to do a presentation on my own to catch up. So talking about linear algebra that represent by myself. A linear algebra is simply study about the factors, factor spaces, matrices, and linear transformations, dealing with linear equations, linear functions, and representations to matrices and determinants. So the history of system of linear equations introduced in 1637 by René Descartes that coordinates in geometry that we known to solve big problems about this one. What's the course outline? There will be two: introduction to factors and matrices, and the second one, determinants and Cramer's rule. Starting off with factors, we already learned from the high school before, between the difference of scalar and factors confirms that scalar has only a magnitude, the factor has both magnitude and direction. Following the summary below, based on the written as -2, 1, 3, 6, believe that factor is an ordered list of numbers. Scalar is also called numbers. Number of elements are the list that includes entries, coefficients, components. Number of elements in the size of the factors are dimension and length, and many more. Following the factor based on the formula has row or column. And so does the factor operations about the factor addition, factor subtraction, and factor multiplication. Example from known for factors are there are three answers that problems out to solve. Number 1 to 3 that recommend from addition, subtraction, and multiplication. Next, what's about matrices? The key concepts mathematics that widely used for solving equations and problems such as physics and computer science. Matrix is simply a grid of numbers, determinant that value calculated from a square matrix. So there are types of matrix, but not all, but there are 12. The first one is singleton matrix. The second one is null matrix. The next one are horizontal matrix and the vertical matrix, rectangular matrix, square matrix, diagonal matrix, scalar matrix, identity matrix, a singular matrix, non-singular, and symmetrics. Same as we already learned from addition and subtraction, so I'm going to skip this one out. And so that's the scalar multiplication. So the formula of A and B is exactly based on follow the instructions of row and column. But if it's reversed, it will totally different answer. I will skip this one out. So the multiplications, this is going to be a difference. This one, there has to be a two directions that is which totally different. So A and B, which is the final result based on the 2x2 matrix, and the matrix BA confirms it is 3x3 matrix. And this is the example 14 for what we learned from multiplication. Now the determinant x, so starting with 2x2, so following the formula based on the determinant, I'm going to skip this one out. And remember, once I forgot that way, if it's non-singular means not in the zero, which means the results of all that rows or columns are linearly independent, which is called non-singular. And if it does exist the same that is zero, which is called an infinite number of possible solutions. So it is called the not a single matrix. And one more, a single matrix is one in which there exists linear dependence between at least two rows or columns. So this is one the example for 2x2 matrix. So I'm going to focus on third order determinants. So third order determinants divided into three elements. The first one on the A that using on the top left, the B1 on the second element using on the middle top, and lastly on the third element using the top right. And here are the example of the formula and the example recommended. So next one, 2x2 matrix. So we use this system AXB. So the A you use it for coefficient matrix, X will be using for variable matrix, and B using for constant matrix. If completing all those solutions by coefficient matrix takes the result of the determinant A that we use for dx for the constant matrix to determine the value of x and y. The next of 3x3 matrix, same as likewise, but determine the value of x, y, and z as well. And important the notes based on the Cramer's rule conditions. Any case of finding solution using Gauss-Jordan method, where the determinant matrix is 0, cannot find the solution. It has important note based on the description below. And here are the example 1. And so that's the example 2. And that's basically it. We learned about the factors and metrics that we learned from high school. And so that's the Cramer's rules. Hope you guys really learned some knowledge about the mathematics. And so that's the linear algebra. Thank you guys for watching. I apologize for the mistake. I should have improved for the next presentation ahead. So thank you so much, especially Sir Eliando. Thank you very much.